Insulation Nation by Jacob Sammons and Corbyn Sherburn. What is our project? Our project is to test pipes to see which retains the most heat. We will test pipes with and without a polystyrene sleeve or styrofoam sleeve. Our goal is to find out what is the most expensive and inexpensive, and our hypothesis is that the glass pipe without the polystyrene sleeve will be the least effective. What materials? We will be testing various pipes used in plumbing. All pipes used are 3/4 inch in diameter and 5.5 inches long, such as steel pipe of 2 end caps, copper pipe of 2 end caps, a glass pipe of 2 end caps, and a PVC pipe of 2 end caps. For the experiment, we will need other things such as a digital thermometer, a hot plate, and a beaker that holds at least 25 milliliters of water.
Material costs. All displayed prices are 3/4 inch pipes that are 10 inches long. The copper is $12.97. Steel is $12.25. PVC is $1.85. And glass is $2.45. The polystyrene sleeves are under $2 per 6 feet. Experiment steps. Step 1. Heat up 25 milliliters of water on a hot plate to 40.5 degrees Celsius or 105 degrees Fahrenheit. Step 2. Pour 25 milliliters of water into the copper pipe and put the temporary cap on it. Step 3. Put the simulated pipe into the testing environment, which sets at about 73 degrees Fahrenheit. Step 4. After 15 minutes, record the water temperature inside the pipe and dump out water. Step 5. Repeat steps 1 through 4 with all the other pipes. Step 6. Repeat step 1 through 5, but this time with a polystyrene sleeve around the pipe.
Experiment results, but without the polystyrene sleeves. The PVC pipe went from 40.5 degrees Celsius down to 30.6 degrees Celsius, which is a negative 24.4% change. The glass pipe went from 40.5 degrees Celsius to 28 degrees Celsius, which is a negative 30.8% change. The copper pipe went from 40.5 degrees Celsius to 25.6 degrees Celsius, which is a negative 36.7% change. And finally, the steel pipe went from 40.5 degrees Celsius to 23.9 degrees Celsius. That is a negative 40.9% change. Experiment results, but with the polystyrene sleeve. The PVC pipe went from 40.5 degrees Celsius to 30.8 degrees Celsius, which is a negative 23.9% change. The copper pipe went from 40.5 degrees Celsius to 29.4 degrees Celsius, which is a negative 27.4% change. The glass pipe went from 40.5 degrees Celsius to 28.8 degrees Celsius, which is a negative 28.8% change. The steel pipe went from 40.5 degrees Celsius to 24.3 degrees Celsius, which is a flat negative 40% change.
Here are the two graphs that show the data that Corbyn just showed. Why insulate? Heating water can usually cost around or above $20 annually. But if you insulate your pipes, you can save $8 to $12 annually. Less electricity used heating means less coal burn and less pollution.
Real world example. So last winter break, my family went on vacation for a week straight. When we returned home, we realized that the pipes had froze, being as there was no more running water. And what we ended up doing is we used space heaters to try and thaw the pipes, hoping there was no serious damage. When the pipes did thaw, we realized that there was a hole in one of the pipes as it sent water right down into the crawl space. The pressure was so immense, it sent the faucet in the kitchen right off of its own sink. What we had to do is we had to call Delco, and they have to turn off the water, and then we had to redo some of the plumbing. Our conclusion. PVC pipe with polystyrene insulation ended up being the best for heat retention and energy efficiency. It also happens to be the cheapest pipe we had. Our hypothesis was incorrect, and it was not the glass pipe without the polystyrene sleeve that was the least effective, but rather the steel pipe without the polystyrene sleeve.
If we were to do something different, we'd construct something to constantly record the data with the cap on. In the end, insulating your pipes will help you save money on your energy bills. It requires less energy and requires less coal to be burned, and in the end, less pollution.